Previously, we talked about the special right triangles, the 30, 60, 90, and the 45, 45, 90 degree triangle. Now, not every right triangle is going to be a special one like that. Today's information, talking about the 6 trig functions, is going to help us find sides and angles of all different types of right triangles. So let's jump right in. Today, these 6 trig functions are ratios that can only be used on right triangles. So that's our focus for this whole unit, is right triangles. So, for example, a right triangle means it has a 90-degree angle in it, and as always, the side across from that right angle, the largest side, is called the hypotenuse. It's our most important side. Okay. Some other things to make note of. This red letter right here, this symbol, this is theta. Okay, it's a Greek letter, and it's usually used to represent an angle. So either an angle we don't know or an angle that they're trying to mark. So underneath here we have two right triangles. Let's say I was to go to this corner of this triangle. That's my focus angle. I'm going to call that one theta. Okay? No matter where I place the theta, let's see. The side across from the 90, that's the hypotenuse, just like always. And now we're going to put some different names on this. Okay? So hypotenuse is always the longest side. The side across from my theta, okay, so we're not going to tell how big it is. We're going to put a name on it. The one across from my theta angle is called the opposite side. Okay, it's across from theta. So we have the hypotenuse is the longest, opposite is the one across from it. So let's see. The side that is touching theta, so we're talking about this one down here, that word is adjacent. Adjacent or touching theta. Touching or next to. So that's a setup like this. Let's go over to the other triangle now. Let's say I called this angle up here theta. Some of my side names are going to change. The one that will not change is the hypotenuse, because the hypotenuse is always across from the 90. It's always the longest side. So hypotenuse. This time the opposite has changed. The side that's across from the opposite is now this one on the bottom. So this is my opposite side. You see how that's across from our theta symbol? So I have the hypotenuse, I have the opposite. That means this side over here now is the adjacent side. And that adjacent side is the one that's touching the theta symbol. So depending on where the theta is, sometimes the words change around, but they're always there. There's opposite, hypotenuse, and adjacent. Now those words are going to be important for us when we actually look at the 6 trig functions here. So I've got two tables, 6 boxes altogether. Here's new words for you. All right. So the 6 trig functions, the first 3 are called sine, cosine, and tangent. So that's the full spelling of them, sine, cosine, and tangent. Now mathematically it's a lot of letters to write out each time, so sine is reduced to sin, and sine of an angle, theta. Okay, so that's how we write it, sine of theta. Cosine gets reduced to cos, so cosine of theta. And then the third one, tangent, is tan, tangent of theta. These are the first 3 trig functions, so 1, 2, and 3. Now what's important for us to understand is these are ratios, so they're going to be fractions here. And they're all different ones. So sine is a ratio of the opposite side over the hypotenuse side. So opposite over hypotenuse. Cosine is the ratio of the adjacent side over the hypotenuse. And then tangent is the opposite side over the adjacent side. So if we're able to remember the first 3, the other 3 trig functions are pretty easy. Now the one that goes across here, so sine, cosine, and tangent, they have opposite ones. Okay, opposites. And the way we find these is just by flipping all of our ratios over. So sine gets connected with something called cosecant. And here's the full written out word, cosecant. Cosine gets flipped into what is known as secant. And tangent goes with cotangent. So if you remember the first three, the other three are easy to know because you just flip the order of these. So cosecant is written as CSC theta, cosecant. Secant is SEC, and cotangent is COT. So again, these are all just the flips. So cosecant and sine go together. So that means we're going to flip this one over. So if sine is opposite over hypotenuse, cosecant is going to be hypotenuse over opposite. So just the flip of the fraction. So let's flip secant now. That means hypotenuse over adjacent. And cotangent is the flip of tangent, so it's going to be adjacent over opposite. So here's one way to kind of either memorize or look at these. The next thing I want to show you is a little shortcut to figure out what these are. All right, so if you want to make a note of this next part, a little acronym for us. All right, so just like PEMDAS stands for parentheses, exponent, multiplication, division, addition, subtraction. For the six trig functions, we've got one called SOHCAHTOA. All right, so here's just a little way to remember stuff. So starting from the left, so S stands for sine, and that's going to be equal, and let's see what it refers to. Sine is opposite over hypotenuse, and look at those letters there, opposite over hypotenuse. So if you want to write them out, you can. Sine is opposite over hypotenuse, and we just follow the patterns here. Cosine, that C stands for cosine, is adjacent over hypotenuse. And the last one, T, TOA, stands for tangent, is opposite over adjacent. So either refer back to the tables or SOHCAHTOA. I'll be referring to that word in the future. And it only has the first three because the other three, remember, are just the opposites, the flips of these. Cosecant, secant, and cotangent, just the flips of all of these. All right, so SOHCAHTOA. So let's go ahead and apply this to our first example. So this example is going to tell us to find all six trig functions. Trig functions or trig ratios. Trig ratios. Okay, but in order to do that, we need our triangle here. Has to be a right triangle. Okay, now they're going to give us some sides on this, and they're actually going to give us all three sides. We've got a 3, a 4, and a 5. Now the important thing that we don't have yet is theta. They're always going to label one of our corners as theta. The 90 never gets labeled as theta. It's going to be one of the other two, and in this case they're going to label the top one. So I need to find all six trig functions. And remember the 6. You can either write them out first or write them out later. The 6 are sine, cosine, tangent. Okay, that's what those are. And then there's the other 3. The one that goes with sine is cosecant. The one that goes with cosine is secant. And the one that goes with tangent is cotangent. Those are the 6. So we need to find out all 3 of those. And if I look back up at the tables, they're just made up of these words: opposite, hypotenuse, adjacent. If I were to label the sides of my triangle with those words, all I need to do is fill in the numbers. So let's take a look. This is my triangle over here on the left. Hypotenuse is always the important thing that we found first. So of the 3, the 4, and the 5, The 5 is the longest. It's across from the right angle. The 5 is the hypotenuse. All right, so we label the hypotenuse. Let's go ahead and find the opposite and the adjacent. The side that's across from the theta angle, that side over there, the one that's across from it, that one is the opposite. So 3 is my opposite side. All right. Now, seeing all that's left, we have opposite, hypotenuse. The only thing that could be left is the adjacent. And is that side touching the angle? Yes, it's touching. It is next to. So there's my adjacent. And once we have everything labeled, we just fill these in. So thinking about the word, and I'll bring it up right here. SOHCAHTOA, we're looking for sine. So sine is opposite over hypotenuse. Opposite over hypotenuse. So which one is my opposite number? Let's look over here. Opposite would be the 3. And the hypotenuse is the 5. And there you go. Sine of theta is 3 over 5. That's all you got to do right now. Cosine, if we're looking back up at SOHCAHTOA, cosine is adjacent over hypotenuse. So the adjacent side is 4. The hypotenuse is 5. And finally, we're looking for tangent. Tangent is opposite over adjacent, TOA, opposite adjacent. So the opposite is 3, and the adjacent is 4. Now remember, for the other 3, cosecant, secant, and cotangent, it's just the opposites of all of these. So we could just flip all the numbers or flip the words, however you want to do it. Cosecant is hypotenuse over opposite, or just flip this fraction here. It's going to be a 5 over 3. Secant is hypotenuse over adjacent, or flip this one here. 5 over 4. And finally, cotangent is the flip of tangent, so that's adjacent over opposite, or flip this one, 4 over 3. So you have found all 4 trig functions. Or sorry, not all 4, all 6. All 6 trig functions. All right, let's try another one. So, for example, another right triangle. They give us some sides, 18, 6, and 10. And again, the important thing is, where is theta? Theta is going to be located up here. So let's use that information to label our sides. Hypotenuse is always the longest side, always across from the 90, so that's the 18. Hypotenuse. The opposite is the one across from the theta, and that's going to be the 10 this time. So 10 is the opposite. 6 is connected to that theta symbol here. It's connected, so that side is the adjacent. So again, let's find all 6 trig functions. Sine, cosine, tangent, and then the other 3, it goes, whoops, cosecant, secant, and cotangent. So this time I'm going to do it without writing out the words. Sine, if we think about SOHCAHTOA, so, sine is opposite over hypotenuse, so, opposite hypotenuse. So opposite is 10, hypotenuse is 18. For right now, that's okay. Maybe later on, they're going to ask you to reduce those numbers, and that would reduce to a 5 over 9, okay, simplifying fractions. Cosine, so AH, adjacent over hypotenuse, adjacent 6, hypotenuse 18. Tangent, TOA, opposite over adjacent, so opposite 10, adjacent 6. And then the other 3 are just the flip versions of all of these. So cosecant flips to 18 over 10, secant is 18 over 6, and cotangent 6 over 10. And there we go. Without writing out the words, we're still able to find these things. So that's finding all 6. Now there will be some problems where it just tells us to find certain ones. So let's say find the sine of theta for the following triangle. So again, it has to be a right triangle. Mark that. So I have a 16, an 8, and an 8 square root of 5. And my theta symbol is going to be over here. Now this time it's not asking us to find all 6. It only wants us to find sine. And sine as a ratio. Sine, so katoa, so, opposite over hypotenuse. I don't need to find all 6, I only need to find this one. So I only really need to label the opposite and the hypotenuse. So the hypotenuse is always the easy one to find. It's across from the 90. So this one is your hypotenuse, the 8 square root 5. So there's hypotenuse. But we need the opposite. So there's a 16 and there's the 8. The one that's across from theta, away from theta, is the 16. So that's my opposite. Now the other one would be the adjacent, but we don't need it for this problem. Okay, it's just asking us what sine is. So sine of theta, again, is the opposite over the hypotenuse. Or in this case, I'll write it next to it. Can't erase that. Oh no. So the opposite is 16. Okay, see there's 16. Hypotenuse is 8 square root 5. And this time we're actually going to reduce it as much as possible. The 16 and the 8 are like terms here. And 16 over 8 is a 2. So 2 on top. And now the 8 disappeared, so on bottom is still a square root 5. And we're okay with that. Can't reduce it anymore. So the sine of theta is 2 over square root 5. And let's try one last one. So, for example, has to be a right triangle. 12, 13, 5, and this time they mark theta as this bottom one here. So knowing all these problems, we're going to have to find the side names. Now let's see what the instructions are. Let's go ahead and find the tangent of theta. So knowing that, we're not trying to find all 6, we're just trying to find the tangent. So the tangent of theta, so katoa, opposite over adjacent. So we need the opposite and the adjacent. So the opposite is always across from the theta. Opposite is across from the theta, so that's going to be the 12. And the adjacent is the side touching theta. But we got to be careful this time because there are 2 sides. The 13 is actually the hypotenuse because that's across from the 90, so that's not the adjacent. So we don't actually need that one, not for tangent. The one that we need is the 5. Okay, see that's the side touching the theta, but it's not the longest side, so this one is the adjacent side. So setting this up, we need opposite 12 over adjacent 5, and that does not reduce anymore, so the tangent of theta is just 12 over 5.